Hi, this is Alfauzia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is Venn diagram in probability. First, let us see what is meant by a Venn diagram. A Venn diagram is also known as Euler Venn diagram. It is a simple representation of sets by diagrams. The usual depiction makes use of a rectangle as a universal set and circles for the sets under consideration. Now let us take a look at some basic formulas for Venn diagrams of 2 or 3 elements. Here are the basic formulas. N of A union B is equal to N of A plus N of B minus N of A intersection B. Same way, if you are considering for 3 events A, B and C, N of A union B union C is N of A plus N of B plus N of C minus the intersections plus the intersection of the 3. So it goes on like that, where N of A, N of B, all these are the number of elements in that set. N of A is nothing but the number of elements in set A. N of B is number of elements in set B. So once you understand the concept of Venn diagram with the help of the diagrams, you don't have to memorize these formulas. You will understand the concept. Here is a figure I have posted. This is the Venn diagram in case of 2 elements, A and B. Please look at this figure carefully. We have X, Y and Z. X denotes the number of elements that belong to set A only, and Y denotes the number of elements that belong to the set B only. And please look at this portion, Z. This is a common part in between these two. So Z refers to the number of elements that belong to set A and B both. This is the region common for both A and B. Do you understand the difference between X, Y and Z? These are just for that part alone, and Z is the common area. And W. W is the number of elements that belong to none of the sets A or B. So from this figure, it is clear that N of A is the number of elements in the set A. This circle has X and Z, so X plus Z. So what would be N of B? In this B, you have Y and also Z, so Y plus Z. These are all the elements in the set B. Now let's find N of A intersection B. Intersection means the region in common. So the region, number of elements in the common region between A and B is just Z. What would be the union? Union means it includes all the elements. So in both A and B, we have X, Y and Z. So this would be equal to X plus Y plus Z. And what about the total number of elements in this diagram itself, in this entire set? You have X, Y and Z. These are the elements in the event A and B. And there is one more element, W. So total number of elements in this Venn diagram is X plus Y plus W plus Z. So these are the terms you should know when it comes with Venn diagram for 2 elements. Does this make sense to you? Okay, let me show Venn diagram in case of 3 elements. I have made it more clear. Please have a glance over this. There is a rectangle with 3 circles. So the elements are A, B and C. You have components in each. So this is the region where only A covers, and this is the region only B covers, and only C is this. And this region is common in between A, B and C. This particular region covers all the 3 circles, and this is just for A and B. This is for B and C, not A. Do you understand the meaning for this one? This portion alone, this is the common region between B and C, not A. This circle didn't touch this area. W is the number of elements that belong to none of the sets A, B and C. Please have a glance over this figure, then you will understand the concepts. These are the basics of Venn diagrams. If you're comfortable with the basics, then we can move on the example problems. Hope you're clear with this one. So if the number of elements increases, the regions also makes the difference. So in case if you're having 4 circles, most probably will be having 3 circles. But there are also chances to get more than 3 circles. But the concept is same. Only thing is you have to extend the formula. Here is a word problem. Let us solve this problem using Venn diagram. In a college, 200 students are randomly selected. 140 like tea, 120 like coffee, 8 like both tea and coffee. So these are the questions you have to answer. The given information may be represented by a Venn diagram. You can use the same alphabets as variables. For tea, you can use the capital letter T, and for coffee, you can use this alphabet C. So let us create a Venn diagram. You should start with a rectangle. In this problem, they are talking about two events, tea and coffee. So I have drawn two circles. Now let me name them. After naming, let us take down all the information given from the question and enter the values here. 140 like tea and 120 like coffee. 80 like both tea and coffee. You always have to start from the intersection part. 80 like both tea and coffee. So I'm going to enter this number in the center. Start from the intersection part and then exclude that number from the other. So how many like tea? 140 totally like tea. Already we have entered 80. So 140 minus 80 is 60. Am I right? So 60 like tea only. Can you follow so far? Same way 120 like coffee. Already we have entered 80 as a portion of C. So just subtract this 80 from 120. So the leftover is 40. Now the total is 200 and we have entered 60, 80 and 40. So this total is 180. Subtract this 180 from 200. So you'll be getting 20. So 20 comes under none area. So this is how we have to take down the information in a Venn diagram. You cannot just write 140 in this and 120 in this circle. You always have to start from the intersection portion. Write down the intersection portion and then subtract that value from the total. And finally you have to check how many were left for the none area. So the number of students who like only tea is 60, number of students who like only coffee is 40, number of students who like neither tea nor coffee is 20. Number of students who like only one of tea or coffee is 60 plus 40, which is equal to 100. So let me write the answers. Once you construct the Venn diagram, it will be easy for you to answer all the questions. Only few calculation will be needed. The thing is how you enter the values in a Venn diagram. Neither tea nor coffee means the none region. How many like only one of tea or coffee? So you should add the only region. And last part, how many students like at least one of the beverages? So at least means you have to apply the formula here. N of tea, N of coffee plus N of both tea and coffee. At least one means just add all these. So I'm getting 180. You can also use probability of not an even concept. At least one means 1 minus this one, 20. You just have to exclude this 20 from the total, 200. 200 minus 20 is 120. You can follow the method that you're comfortable with. All the Venn diagram problems are very easy and simple. Read the question carefully twice and then start constructing the Venn diagram carefully. Enter the values starting from the intersection portion. Hope you're clear with this example with 2 circles. Okay, let me take one example with 3 circles and explain you how to enter the values and solve the problem. Here is an example. Please read the question twice. These are the parts to be answered. And the main question starting from here to here. In a survey of 500 students of a college, it was found that 49% liked watching football and 53% liked watching hockey, 62% liked watching basketball. Also, 27% liked watching football and hockey. These are the intersection parts. 29% liked watching basketball and hockey both. 28% liked watching football and basketball both, and 5% liked watching none of these games. Okay, let us enter all these information in a Venn diagram. They are talking about football, hockey, basketball. So 3 circles. So if you want to fill in the information, you need some information about this region, which is common for all the 3. But I don't think information is given about this. So first we can solve for that. The region for the 2 circles are given, but there is no information about the intersection part of all the 3 circles. So we are going to solve it using the formula and then enter all the values in the Venn diagram. N of F. F is football, H is hockey, and B is basketball. The percentage of students who liked watching football is 49%. N of H. The percentage of the students who liked watching hockey is 53%. N of B. For basketball, the percentage of students who like watching basketball is 62. Let's find the intersection parts. Football and hockey. So N of F and H is 27. N of basketball, B and H is 29. And N of F and B is 28. Finally, it is given that 5% liked watching none of these games. So F of N of F union H union B. That would be the number of elements within this circles would be just exclude that 5. Can you follow so far? Okay. Now applying the basic formula. Here is the formula. Plug in all the values here. So I'm getting. You can simplify as usual as you do in algebra. Combine all the like terms and group them on one side of the equation. Isolate this on one side of the equation. So I'm getting the intersection part is 15%. Hope you're getting the same value. Okay, we have got this information. Only for this information we did all these calculation. Now let's make the Venn diagram as per the information given. So the region intersection between all the three circles is 15%. So you always have to start from the innermost common region. So this is the region common for all both three circles. Okay, 15%. And the region F and H is 27. F and H is 27. Already 15 is there. So the leftover is 12. The common region between B and H is 29. B and H is 29. So in this portion already 15 is there. So 29 minus 15 is 14. The common region between F and B, football and basketball, is 28%. So this area is 28. Already we have 15 in the center. So 28 minus 15 is 13. Now let us fill in this portion. N of F is 49. So this circle entirely is equal to 49%. We already have 12, 15 and 13. So add all these numbers or just subtract all these three numbers from this 49%. So you'll be left over with 9%. 49 minus 12 minus 15 minus 13 is equal to 9. Same way, N of H is equal to 53. This circle entirely should have 53%. We have already mentioned three numbers in this circle, 12, 15 and 14. Subtract all these numbers one by one from 53%. So I'm left over with 12%. And for this one, N of B is 62%. So this circle entirely should comprise 62%. We have 13, 15 and 14. So 62 minus 13 minus 15 minus 14 is equal to 20. In the question itself, it is said that 5% liked watching none of these games. So 5% outside the circles, but within the rectangle. Always you have to notice this total number of information given in the question. Here it is 500. So the number of students who liked watching all the three games is 15% of 500. Just multiply this percentage with the total. So you'll be getting the answer. Hope you're clear with this problem. In case if you have any query regarding Venn diagram, please let me